Hi all, good afternoon. Thank you for joining this webinar. I am Niveta from Kripya Solutions. People are still joining, so let's give 30 seconds more. Let's wait for 30 seconds and we will start the session. I think most of the people have joined. Welcome you all for the webinar Evolving with Industry 4.0. So the today's speaker will be our Sri Kumar, our General Manager of Kripya Solutions. So I am handing over to him. Welcome, Sri Kumar.
Thank you, Niveda. Sorry for that. Hi, everyone. My name is Sri Kumar. I'm the general manager for Kripya Solutions. I take care of, among other things, the Industry 4.0 solutions which we offer under Kripya Solutions, and Central Stage is the product which we offer under that. To give a brief introduction about myself, I started in the manufacturing engineering services field, primarily dealing with computer-aided design, computer-aided engineering, product lifecycle management, design for analysis, and design for manufacturing and assembly kind of services and product sales. I've worked primarily in the automotive manufacturing white goods space, both from a services and a product side of things. I've also worked with large industrial manufacturers who manufacture industrial level restaurant equipments. For the last few years, I've also worked primarily as an IT solutions person, focusing on reporting and analytics, process automation, among other things. Kripya is a solutions company which deals with product lifecycle management and Industry 4.0 solutions. So, as a part of the seminar, what I'm going to do is I'm going to be doing an introduction to what Industry 4.0 is, how Industry 4.0 is evolving according to industry experts, what we are doing in that space, and also some of the caveats which comes with the industry as to the challenges which we are facing in implementing such solutions. So what I will do as a part of the seminar, as I said, is that I will continue with the presentation and I'll try and wrap my presentation in about 30 minutes. At the end of 30 minutes, we will have 15 minutes where for the first 5 minutes, I will take all the questions which have already been asked on the webinar solution window. And I'll try and answer it, generalize it by grouping together similar questions because there are a lot of questions which are very similar in nature. So let's get started. And if there are any questions, please do raise your hands at the end of it and we'll try and put it as a part of our Q&A session. So what is Industry 4.0? Industry basically started off as a solution which started off with the steam and mechanization. How did industries work? It basically started off with people trying to move from a hand-driven manufacturing segment to more a mechanized manufacturing segment, and steam engines played a big role in that. The first, um, the steam engines played a big role in that. Sorry for that. um, Affordable products like telephone, automotive, and those came in the industry 2.0 with electricity and mass production. And if you remember, Ford was one of the pioneers of the industry 2.0 solutions. Uh, industry 3.0 is where automation and IT started to come and do a big play in it. In 1952, the first CNC machine was invented by John T. Parson under the MIT University. And Cincinnati was the first organization which started off a commercial manufacturing of the CNC machines. Uh, Also, at the same time, a lot of the other automation technologies also started coming up, like punch card based manufacturing and those kind of things. Computers started playing a big play into the industry segment itself. Slowly, as the 21st century started driving industry forward, we started digitalizing our solutions. We started introducing AI driven solutions, and the decision making also was driven by AI. And that's how the 4.0 solutions came into play. And I will try and detail out a little more on the industry 4.0 in my subsequent slides. Now, what is the future? The future is where we are defining industry 5.0 solutions. And what it's going to be is about sustainability, resilient manufacturing, and more human centric interfaces. What I mean by human centric interfaces is that there are going to be a lot more robotics working hand in hand with humans in the industry and providing solutions which will reduce the load on humans. The key technologies driving Industry 4.0, which will come up in the next slide, is driven by industrial IoT. So, IoT means Internet of Things, digital twins, AI, machine learning, cloud computing and edge computing, advanced robotics, additive manufacturing, and so on and so forth. What does IoT mean? And IoT drives a lot of the Industry 4.0 focus. So IoT means Internet of Things, where connection of physical machine to an internet network helps you in data collation, analysis, and real-time integration. So when your machine is running, you will get a real-time feedback from your machines as to what it's doing. Digital twins are where you can replicate your scenario, whether it's a line scenario, whether it's a production scenario, or a complete plan scenario in a virtual environment. And AI and machine learning is basically using the data which you gather from all the above to make more decisions which are machine driven or more computer driven based on your experience and how it is evolving. All the other parts of the industry 4.0, the solution itself brings together the computing power, the cloud based computing power, the advanced robotics and cobots. All these come together to drive the industry 4.0 solution. In the next few slides, I'm going to kind of touch base on what the trends are reshaping the manufacturing segment as we go further into the 21st century and into our next decade. So what NASCOM has found out is that hyper automation, quantum learning led supply chain, 3D, 4D additive manufacturing, industrial metaverse, and circular manufacturing are going to be the key factors which are driving the industry forward. So what do we mean by hyper automation is nothing but AI and AI driven machines will be the next level. You have already seen Tesla having automated driving systems. Similarly, machines also will start to take independent decisions based on the orders they are given. And again, I have a few examples, a couple of examples which will detail out some of these points, and I'll try and also give a history. I mean, give what my take of the future is going to be. The 3D and 4D additive manufacturing is nothing but what we are seeing in prototyping side of things, where additive manufacturing is done to mass produce stuff and not only use it for prototyping purposes but also for small scale production requirements also. And a lot of these manufacturing right now have evolved from more a polyplastic kind of an environment to more metal based environment also, and you can do actually these kind of prototypings in metal based additive manufacturing techniques. The third is quantum learning led supply chain. I do have an example in my next slide which will explain that a little more. So what people are using is leveraging quantum tech and deep learning to potentially optimize not only supply chains but how they are doing business. Industrial metaverse is going to be the next big thing which is going to happen, where digital twin integrations are going to simulate factories for real time. In the sense, you can virtually represent a factory in real time in 3D in moving parts and reconfigure the factories to make sure how your production inputs can increase, what changes will affect production, how space management can be done, so on and so forth. This can be used for a lot of things. You can use it for training purposes, you can use it for presentation purposes, in addition to what you use it from business purposes also. And last but not the least is circular manufacturing, which is going to bring together net zero manufacturing processes in place, improving sustainability, and using materials and reusing materials. You would have seen a lot of automotive manufacturers using plastics which are bought in from the sea to be making their seats or making their fenders and those kind of materials. Also, a lot of the new plastics which are being introduced in the market is more on the biodegradable materials list, and so a lot of these materials can be, they can be used without affecting the nature and keeping our environment safe for our future generations. So this study was done by NASCOM and Bain and Company, and this is a very recent study. This is the 24-25 study, so it's very recent in nature. So, what I'm going to do in my next slide is kind of jump into a customer case study which details out how we are doing the third part of what the NASCOM study says about quantum learning and how decisions can be dealt by not only AI but machine languages also. So, one of our customers, they were basically doing scheduling based on how their ERP was defining what the requirements from their customers were, and a lot of it was also dictated by their manufacturing engineering system, which is MES, traditionally known as, and how they can manufacture that output. So for example, if the customer had 4 products and that 4 products had to be manufactured based on the inputs from the market, their MES defined as to what that product can be, when it can be manufactured, and what is the optimum manufacturing. Now, there was a big gap because there were areas when the material requirement or the product requirement would change based on the customer's inputs. So suddenly, a customer would come and ask, can you increase part A by 10 times and reduce part B by 5 times to get me the same output because I need it for my different products. So that what happened was then they had to go out of the ERP and the MES system and define it through manual scheduling. This lack of integration basically broke down the systems, and the system caused a disconnect between what their inventory levels were, how they could manufacture. So it was not synchronized, and the visibility was not there for people doing non-production jobs to understand how much to order, how much to keep in the stock, and so on and so forth. This led them to not be able to adapt on the run and affecting production and disrupting the whole entire supply chain itself. So they came to us requesting for a solution. And what we did was an optimized solution with a layer of artificial intelligence on top of it. And my next slide will actually detail out how we did it as a flow diagram. So what we did was we used machine learning algorithms to predict what the potential conflicts will be based on an ad hoc change which would come into the system. So for example, a customer would come in and say, hey, can you make more of these product than that so that I can produce more machines at my end? And we would feed it into the system, and system would optimize the whole production schedule and redo it in real time on a ad hoc basis. And this would be integrated back into the ERP and MES system so that it was seamlessly connected, and anybody using ERP like the purchase guys or MES, the production guys, would have a real time knowledge of what the changes were and how their system was predicting the production orders. This allowed them to easily and flexibly adapt. So instead of having to halt the production, restart the production, and change the production, all the team had to do was update it in the system. The system would automatically update it in the ERP and MES systems and basically take the production forward. How did we do it? The next slide explains that. So the system, what it would do is it would import the work orders and from SAP and MES, and have this, the scheduler algorithm would run on top of it, and the scheduler would input the system based on what the requirements were. So it will have a date range, it will have a scheduled date input and carry forward systems, and the system will give an output which the user can review and change it as needed. And once the finalized work orders are being finalized, then the team can basically use it to update the SAP and do the reordering process of it. Once it's finalized, it would go into a scheduler input and basically be sent into the MES system for production. So it basically goes forward with production, and it takes care of everything related to production on the MES system. Now, this was how we defined the system. I'll take a short pause here and see if anybody has any questions until now. If there is any questions, please do put it on the chat. I do have a colleague who's monitoring the system, and he would give me inputs as to any questions related to this at this point of time, and we will be able to answer it in real time or not. If not, we will handle it at the end of the presentation also. So going forward, so this is how we define the whole system. So what was the advantage was that when you import the work orders and the scheduler defines the algorithm, I mean, based on the algorithm defined, schedules the whole program, right? The system was seamless. It just brought in the information, updated it on an ad hoc basis. So they didn't have to worry about doing it on a day basis. They could even change it based on a shift basis also, or even half shift basis. So before lunch, after lunch, whatever they wanted, they could change it in real time and have the MES get updated. Okay, I'm going to jump into my next example, which is based on digital twins or virtual simulation. So, what is digital twin in manufacturing? Digital twin is nothing but a virtual replica of a physical manufacturing process. It helps you continuously monitor. You can do real time analysis. You can do training based on this. And a lot of manufacturers in the high end manufacturing, like automotive, where when they have to reconfigure a whole machine line based on new production inputs, this helps them tremendously. And there are a lot of products in the market done by leading CAD softwares like Siemens or Autodesk or PTC or Deso. They all have products which help you do this. The challenge is how do you model it and how do you do it. So take an example of an automotive industry, right? If they have to change, say, if they're producing a sedan and they go into producing an SUV, how do they change their lines with which can be optimized that both can run? These kind of solutions will help them create it in a virtual environment and run it so that they can take it up and use it for future. So that's how we are defining the digital twin in manufacturing space. And manufacturing, a lot of the manufacturing, it's now trickling down into lower level industries where people who have line based manufacturing and are producing discrete parts, that is basically similar kind of parts with a limited amount of SKUs, they use a lot of this digital twin in manufacturing. So one of the things which digital twin can help, and one of the key benefits of the solution is you can do equipment monitoring in real time. So you can say which equipment is being used heavily, which equipment is being used less, whether there's a mismatch between the equipments which you have in the factory versus your production, and all those things. It also helps in predictive maintenance because you would know what the machine being heavily used obviously would need more maintenance than the one which is being less used. And so those kind of things can be done, which the benefits of that is obviously the reduced cost. You can make sure when your downtime is, you can extend the equipment's lifespan and so on and so forth. The next one is design planning. So testing virtually the ideas before you do. So when you're designing a new engine or a new machine or a new equipment, the system, you can do this virtually before you even put it into action. So before even you design the space, you can put it into action and push it forward. The collaborative process there, because you can bring a whole team, just put it on the screen and virtually discuss the ideas as to how the design planning can be done, is like immeasurable. So you can see it in action even before you put it on the floor. The next one is enhanced training. So imagine that you're bringing a team full of people into the system. How do you train without putting them in risk, without showing them what the risks are? All these can be done by a digital twin. You can simulate scenarios, prepare the employees for the challenges which the scenarios engage with, and you can do a great job of training before even they step foot in the factory environment. You can also use it for your tours, your engagement, your building up your company's portfolio. in markets and showing your shareholders a virtual experience without them even having to come to your local geography in that sense. Now, one of the examples I'm going to show you next is a video. I apologize if it's going to be a little choppy on the video screen because of the system we are using. But what it is defining here is a manufacturer of agricultural machinery. And they manufacture not only whole machinery, but also parts of the machinery. And this one is one part of the whole virtual simulation which we did. So in this simulation, let me see if I have to play it. In this simulation, if you can see it move, basically gearboxes come off the line, and then there's a pressing machine, there's a torque machine, there's a testing center, and the operator is also using it. Now, virtually, you can see how a human would interface with it, a cobot or a robot would interface with it, and how the machine takes care. And if you connect it to a real-time simulation of a factory, as when it goes live, you can even virtually monitor this in a big screen to see when the system went down. So, a lot of advantages this. This can be used for reconfiguring your factory based on new machinery which is coming in, reconfiguring your factory or your line based on new equipment you're trying to manufacture, and so on and so forth. Now, with the automotive industry changing because of engine requirements, like when you go from stage, say, Bharat stage 4 to stage 5 to stage 6, or you're bringing in new CAFE regulations, all these things require a change in the factory line. These kind of virtual simulation tools reduce cost, the overheads which you need to physically configure and bring it into the system. So this is the second and the last example which I wanted to show as a part of the Industry 4.0 solution. Again, we are trying to optimize the time based on how well we can present the information. If you do have suggestions as to what we can do differently or what are the content which you would like to see, please do put it on the chat, and we will make sure that it's included in our next webinar. Now, what I'm going to go for in the next few slides before I close down the presentation, which I wanted to show, is how the challenges are. And this is one of the highest question which was asked even during the registration process as to how do we implement such a solution in our industry. So some of the challenges I'll tell you, and I'll tell you also a solution to it as a part of the Q&A, is that the challenge is the heavy initial investment. It is not from a software side, but there are hardware requirements also which come into play when you want to bring in these kind of things. So when you want to bring in sensors, or you want to connect to PLCs, and you want to connect edge computing systems and bring them together to do your industry 4.0 solution, there is an initial investment. But please do note that it's a one-time investment. So similar to what you're implementing on a machine, this is going to be a one-time investment which is going to give you ROI in terms of better OEs, better preventive maintenance schedules, better visibility of your data, and so on and so forth. The second is a legacy system integration, and we all have seen that the industrial manufacturing segment doesn't change their machines more often unless or until it's a very specialized industry like semiconductor manufacturing or so on. A lot of the press tools which we see in the industry, a lot of the molding machines which we see in the industry have been there for 20, 30 years, and those don't have application interfaces. So one of the solutions which we are doing there is using middleware, which we are also one of it, using edge computing, where we connect the computing system directly to the machine's interface, or bring in sensors, add a piggyback PLC, and then connect it to the edge computing system to get information from those kind of systems. The third is cybersecurity risks. Now, cybersecurity risks are twofold, because if you try to run it from a unsecure environment, then you are going to basically be spending out your data. At this point of time, it might not look like much, but there will be a time when those data will be very important for a lot of people to take decisions who might be outside your industry. So cybersecurity is a very big thing which needs to be taken care of. The solution which we are offering is, we do have an infrastructure team. Personally, as I said, from a Kripya point of view, but any vendor would have an infrastructure team who would be able to set up the firewalls in place, whether it's a virtual firewall or a commercial grade physical firewall, set up an OT network segment where operational technologies are segmented in their own network and not used in the business network, and so on and so forth. So there are definitely a lot of solutions which you can do for your cybersecurity risks and reducing your cybersecurity risks also. The fourth is the workforce resistance. Now, resistance is always there when you're trying to introduce new technologies into the system, right? When you do a change, people are reluctant to change because they have been doing this traditionally in such a fashion. So, what we are trying to do is educate the industry more, teach them how they can do it differently, tell them the benefits of what the system will bring in, and also give them training. And the training can be virtualized, the training can be also showcased in a simulation manner, saying that, hey, look, if you implement it virtually itself, you see the benefits. Now imagine what can be done if you do it in a right manner. The fifth is the data overload. So the data overload is basically, imagine manufacturing machinery like press tools, which pump out like at 60 beats, 60 stamps per second, and so on and so forth. If we're going to capture all these data, the data is going to drive very quickly and very high in such a manner that you will be having 60 data points in a minute. And over a period of an hour, you will have thousands of data points and so on and so forth, right? So what we are trying to put is a more learning language model on top of the data, and also using some of the elastic behavior the cloud environment like AWS provides us to bring in the data-driven analytical solution for real-time analytics to be done on a minute basis or an hourly basis, and take a large subset of the data, reduce it, do the exchange transform load process irrespective of the data being loaded, and present it in a more concise format. So reduce the data overload to the end user by doing the changes or algorithmically calculating what is needed for the end users to take a decision. So we have spoken about challenges and solutions. Now let's speak a little bit of the benefit to end users. Now what I've done is I've kind of broken it down into four areas. What the benefits the ownership would get, what are the benefits that a company management would get, what are the benefits which a plant head would get, and what are the benefits which line in charges or supervisors or shift in charges would get. Now, ownership, it is definitely right that the more data they get, they can improve their profitability by optimizing their operation. They can enhance competitiveness and market positioning. Lot of industries which are above, like in automotive, are asking traceability solutions. So if you implement Industry 4.0 solutions, you can improve the data. You can also showcase the data back to your end users. I have had customers who are in the automotive field asking traceability solutions for individual subcomponents, like for example, safety components or drivetrain components, right? When was it manufactured? Was all the manufacturing process followed to the T? When was it shipped? All those traceabilities, right from the cradle all the way to the grave, is tracked with Industry 4.0 solutions. It is very similar benefits which the management team gets, but management teams are not the what we consider as ownership teams, but the people who are driving the organization, right? What it gives them is the real-time visibility into operation. It also gives them an improved compliance not only with regulatory and sustainability standards but also with their customers, and they can also take quicker decisions, faster decisions, and more accurate decisions because they're using data from their own factory to take the decisions. They're not guessing, but they're doing it there. So I'll give you one more small example, right? You know that you can set up your IoT to capture data across a year, and you can go back and look at the trends after you do a year. You will see there are peaks and troughs in the manufacturing because of a lot of things. Like when Diwali comes around, your production will go down, and a week after Diwali, you will still see the production go down because people have not joined back, and your production environment is not still catching up with your production. Similarly, a weather event driven, those also can affect production. Now, if you put a layer on AI, right? And this is going to be in future, this is not going to be soon, right? You can even do weather prediction patterns to connect your data of production and predict how much production you can get based on weather patterns also. These are some of the possibilities in the future. What do plant head get? Plant head gets a complete visibility of their line. They can make sure the safety systems are in place, they can reduce the downtime because they will know when the maintenance schedules are happening, and they can utilize their resources at the highest possible efficiency rates. Line managers, they can get real time view of what is happening. They can know per hour whether the production count is right, whether they are matching their target production. they can also improve their quality control systems, and they can improve their workforce safety. So these are some of the benefits. There are a lot of intrinsic benefits which Industry 4.0 solution brings in, but with the time constraint what we have, we wanted to make sure that we cover whatever we could. So these are some of the things which we wanted to cover, and that basically brings to an end as to our presentation. I will also give you a quick background of what Kripya is. We are a 18-year-old company. We have a global presence with offices in the US, in India. We have been pioneering engineering excellence with innovative solutions. So we work on PLM solutions. We work on Industry 4.0 solutions. We work also on software development solutions. We also have MES, that is manufacturing engineering solutions experience also. From an industry point of view, we are ISO certified. We also have associations with organizations such as Siemens, AWS. We are also cloud enabled, and our solutions work on all the cloud platforms of the world. So that kind of like brings in, that's my final slide, and I'm going to kind of like uh, do a conclusion slide of how evolving with Industry 4.0 is going to help you. It's going to help you to adapt, innovate with emerging tech. It's going to help you stay agile in today's digital first world. It's going to help you leverage the data and bring the connectivity that can help you grow. And so we truly believe that the Industry 4.0 solutions will give you the best out of what you have today and help you improve. So I'm going to kind of like thank you very much for your time and interest today. I'm going to pause here for almost 30 seconds and take in any questions which are there on the chat. And also, we're going to unmute the system. So if you have questions, please feel free to raise the questions directly on the system itself. You can unmute yourself and you can speak. So one of the solutions, how it was posted on the system was, how will it impact future? Now, the way it is going right now is there are a lot of, I mean, it is a top-down approach, right? The people, if you're a supplier to a different industry, and if they are going to be integrating IoT solutions soon, they will ask you also to integrate these solutions, because then it will give them a complete visibility as to how the equipment was manufactured. Again, I'll give you a small example. Imagine that you are manufacturing airbags for a automotive company, but airbags is one module of a safety system of a car. The other things involve brakes, the ABS system, the switches which trigger the ABS system, and in future, when you're going to have ADAS system, those all come under the safety module. Now, if you don't supply the traceability solution, and the equipment manufacturer, which is basically say Maruti or Isuzu or Daimler Benz or whoever it is who's taking your component and does it, and if their component gets into an issue, the traceability solution is expected back all the way to who manufactured the original part. And if you don't have an Industry 4.0 solutions, you will have a challenge there when you're getting those kind of traceability questions. So industry is going to go in that way in the future, and Industry 4.0 solutions are going to help you get there. The next question I have is, what are the resource requirements that will be needed for implementing such a solution? Now, from a resourcing requirements, if you have an IT team inherent to your organization, they should be able to define the hardware, primarily the computing requirements to it. But my suggestion is always to go with a vendor to implement it, because it's a one-time implementation, and maintenance can be done by anybody from your maintenance team itself, because most of the hardware, which are going to be sensors or PLCs, you would already have inherent capabilities or in-house capabilities to maintain them. The only requirement is to connect it to the software, which any competent company like Kripya would be able to do it for you, hand it over, and maintain it for you going forward. I also had questions on how this would affect PMS and EMS. So Industry 4.0, one of the biggest things is, how do you reduce your energy consumption, and EMS systems plays a big role in it. And PMS, there are two ways you can look at it, whether you want to do parameter monitoring or you want to do production quality monitoring or production monitoring system, right? And both of these places, Industry 4.0 solutions will give you great insight as to how your product is getting produced, what is the downtime on the machine, what are the causes of the downtime, whether it's an operator inefficiency, it's a machine inefficiency, It's a, so all those factors, you will have very good visibility. Instead of having to do a calculated guess, you will have real time data to take a decision on that. Those were the major questions I had. Also, there is a question which is an overarching question which says, how do we implement a 4.0 solution, right? So Industry 4.0 solution is vast. I mean, even our own solution has 8 modules in it, right? And you can do it in a modular way. One of the initial ways you can do is monitor systems which are already connected. So for example, energy monitoring systems, it's a low entry point where you can connect energy monitors or energy metering solutions and then connect it to a edge computing solution and see how your energy is being used, optimize it. The second is OEE. A lot of the new machines which have PLCs can output the data, which you can interpret as to how your production is happening, how your downtime is being calculated, and so on and so forth. Traceability is one great area where, based on all these data, you can trace from how the manufacturing is, I mean, how the product is being manufactured right from the raw material stage to the end of life stage. So these are some of the things. One approach I would usually take is to do it on a modular structure, set first level, but on a complete line basis. That way you get benefits. So if you're doing AMS, please do it for the complete line or the complete plant instead of doing it for a few machines, because then you would not get the complete view. So take a slow burn approach and then go forward and do it a full-fledged implementation, and then do a universal data readout on that. So those are the only questions I had. So I'm going to stop here. If you have any questions, I'm happy to answer them.
Hi, Sri Kumar.
Hi.
Yeah. What are the components, external components can be integrated with industry 4.0?
So external components which you can integrate with Industry 4.0 solutions are your scheduling process solutions. So whether you're bringing in your scheduling process on a third-party level or from something like an ERP solutions like SAP or JD Edwards or something, that you definitely can integrate. You can integrate these solutions to your MES solutions, like so for example, Siemens has Op Center, Deso has their own solutions, and you might also have homemade MES solutions. You can connect these IoT solutions to the MES solutions. That way you will have a complete 360-degree view of your data. Now, there are also systems which you can connect to these IoT solutions for a better view also, like maintenance solutions. If your machine maintenance is there, right, those data
Mm,
can be taken and you can do preventive maintenance or predictive maintenance kind of schedule. So any kind of solution technically used in an industry, you can connect it to get a 360-degree view, whether it's your billing, production data, also compared to your traceability solution. All those can be interconnected, and that will give you a complete view. Lot of it depends on your industry requirements also.
mm, mm, mm. Okay. Good to know that. And does
Hello.
it will impact any people who have been standing in the shop floor, the people who have been operating the machines, how they has to be equipped right to this technology?
So, so what I term Industry 4.0 solutions, I equate it to your readout of your car speedometer, right? It tells you how
Mm,
fast you're going, how much you're uh, engaging your engine with, what gear you're in. It's all visibility, right? Now, when
mm,
we look at like 20 years back when we were driving ambassadors or the Fiats of the world, at that point of time, you had a speedometer which will tell you how fast you're going, how much fuel you had in the engine. But today's digital readouts can tell you what is the battery, what is the voltage in your battery, what is your coolant temperature, how much fuel you have, what is your distance to empty, and all that. And people have evolved, right? The more information they get, more they understand the product. It's kind of like data is always good, and more data gives you the visibility. So imagine if I correlate to a manufacturing segment, right, where
mm,
people were saying, okay, I know in an hour I can produce 1,000 components. But do they, and over a period of a day, if I'm working 8 hours, I can produce 8,000 components. But do they know that between 8 a.m. and 9 a.m., I produced 1,200 components, but just before lunch, I produced only 800 components, and my total was 8,000 components? That visibility is what an IoT system would give. I hope I answered your
Mm.
question.
Yeah, got it.
Good afternoon, everybody. Shall I ask a question?
Please.
My question is, do Industry 4.0 make use of the innovation tools like design sprint by Americans or technic Russian innovative solution TRIS by Russians? Any of this innovation methodologies are using during the development of Industry 4.0 or implementation of Industry 4.0 in any of the area?
So yes, to an extent, but the overarching answer is actually no. But I will tell you where the no comes in and where the yes comes in. Yes comes in because we are using a lot of the large language models which are developed across the world, right? And what are large language models? Nothing but the way you are teaching a machine to understand data and use it for AI. So those kind of technologies are now predominantly coming from the Western countries like Europe and US, and to a little extent from China also, with DeepSeek and all coming into play. So those kind of technologies and overarching layer on the data when you put at AI, they give you better insight. So you definitely are using AI information to better your Industry 4.0 solutions. Now, the reason why I said no is physically we are not using technologies which have not been in the market for, I mean, technology what we are using for Industry 4.0 solutions have been in the market for almost 10 years. You're primarily connecting it to PLC, you're bringing in data from sensors, all these things are available in the market. So there's no new innovation from there. But uh, as a company, we are also introducing new optics based innovations where we are using camera, we are using infrared views and those kind of things to kind of like get more data. So one of the solutions which we are working with one of our partners is they manufacture engine case, I mean the whole engines, 3 cylinder 4 cylinder engines, and they wanted a solution where it would detect on the system itself if a wrong component was implemented, in the sense if they put a wrong component and try to assemble it, because a lot of these parts are interchangeable, right? And for a specific engine a specific part has to go in, like fuel systems or exhaust systems and so on and so forth. So what we are putting is a camera based system which will look at it, connect it to the purchase order or the production order number, and figure out whether the right component was implemented. So if you're looking at it, those kind of solutions, even though the solution per se is traditional, but the implementation of it is new for the Industry 4.0 solution. Again, I hope my answer was a little long winded, but I hope I answered your question.
Okay, sir.
So we have 1 or 2 minutes left in the timed thing. If you do have any questions, please feel free to reach out to us at Kripya. We have our generic email IDs, and my colleagues would be more than happy to collate it. If most of them, the answers will come directly from them, but if there are any questions which we will work through our technical team and answer, we'll be happy. Again, I'm going to shamelessly do a pitch of my own company. We do offer Industry 4.0 solutions. So if you're looking to implement Industry 4.0 solutions, we'd be happy to have a conversation with you. Feel free to reach out to us, and we will have any conversation without any commitment to it. So no bad conversations can be had with us in that sense.
Good afternoon, Sri.
Yes,
Is it, you can hear me, right? Yeah,
yes, yes.
this is Nagaraj from Karnataka, as a working as
Uh-huh.
assistant professor. So our
Okay,
plan is I want to implement one industrial 4.0 to our lab, to the our
okay,
for the mechanical engineering student, not related to
okay,
the 3D printing. Apart from 3D printing, I want to implement one lab, small lab.
okay.
So in this regard, so I need your support to implement and your ideas and some I need to information about the information. So I will reach out to you personally and if you share me your email ID. Otherwise, I will share my email ID to you.
Sure, Nagaraj.
So
I mean, so we will be sending some feedback surveys also. And
okay.
also you can reach out. So if you drop a note to sales@kripya.com,
Mm-hmm.
I would be more than happy, because that email, I also get a copy, and then I will communicate to you my personal email from the organization. We can touch
Mm-hmm.
base and we can take this offline on that conversation.
Because even I'm doing my PhD research on industrial 4.0 impacts on the lean manufacturing system as a PhD.
Sure, sure.
So even I want to that I want to implement in our lab and like a digital technologies like a 4.0.
Sure.
Mhm. Sure.
So we do.
And
I do have some ideas which I can bounce off you, and then we can work on that. That should not be a problem.
definitely, I have some case studies and research paper which I have. I think definitely I will talk with you personally, and I will put it on the mail also. Possible.
Sounds good. Yeah.
Yeah.
So
Thank
we are at the top of the hour. So let me do a final word. Thank you very much for taking the 45 minutes out of your busy schedule. I know a lot of you have come to this meeting from your busy schedules. I hope whatever I spoke about was informational, informative, and impactful to you and was helpful to you. Again, as I said, please do reach out to us at sales@kripya.com. We are happy to have a conversation. Even though the mail ID says sales, we are not expecting that every engagement would end up with a sale for us. But if you are looking at a solution, we believe we are very good at what we do, and we would be able to give you a good solution to whatever you're looking for. Thank you very much. You have a nice day. Take care. Bye bye.
thank you, sir. Thank you.